In this video, we will be using experimental data to write a rate law. I can see that there are 2 reactants and there are 3 experiments. Let's start off with finding the order of reaction for my chlorine. I'm going to look at the other reactant and pick 2 of the experiments where nothing changes. And that would be experiment 1 and experiment 2. And then I'm going to set this up. It does look like experiment 2 has some larger numbers, so I'm going to put that one on top. So I put the rate law for 2 on top of the rate law for 1, and then I'm going to put my numbers in. I'm going to simplify and then cancel like terms. So my rates do cancel, and I will have a 2. My rate law constant will cancel because it's the same one because it's the same reaction. And then these 0.25 to the x, I can cancel those. And so I'm left with 0.5 divided by 0.25, and that when I divide, well, I'll get a 2 to the y, and the idea is to solve for that exponent, and y would be equal to 1. So I know that Cl2 is a first order reaction. Now I'm going to repeat everything for the NO. This time the experiments I'm going to pick for the NO, the ones that stay the same, are experiment 2 and experiment 3. And it does look like experiment 3 is bigger than experiment 2. So if the exponent is smaller, it's a -5, that actually means it's a bigger number. So I'm going to use those 2 rates. And so let me just clear things up. So I'm going to put the rate law of the experiment 3 on top of the rate law of experiment 2. And then I'm going to plug in my numbers. And then let's simplify and cancel like terms. So I can divide my rates and I get a 4. And my rate law constants are the same, so I can cancel those out. And then I can cancel out my 0.5s to the y. And then I'm left with 0.5 divided by 0.25. So that would be a 2 to the x. So what is x? X is a 2. So it is second order with respect to NO. So I can answer the rest of the questions. What is the overall order of the reaction? Add up the exponents. So 1 plus 2. The overall order is a 3. What is the rate law? I do rate is equal to K. And then I know that my NO is a second order reaction and my Cl2 is a first order. And you don't have to draw the 1. If you drew it though, they wouldn't mark you wrong. It says solve for K, the rate constant. So let me clear up this work. I'm just going to rearrange this. So I have K is equal to the rate divided by those concentrations. And then I just need to pick one experiment. And it doesn't matter which one you pick. I think I'm just going to pick the top one. So my K is 9.15 times 10 to the -5th. And that is m to the -2, because there's 2 of them in the denominator. And I have a s to the -1. So those would be the units. This is a third order reaction. And so my K, my units are going to look like that. And then the very last one, it says, what is the rate when NO equals 0.3 and Cl equals 0.6? And that should be a Cl2. So all I need to do is, again, just take the rate law and then plug those numbers in. Let me clear my work. I want to keep my K, so I didn't erase that. So I have rate equals K times these concentrations. And then just plug in what they give us. So we just found K, so we can plug that in. And I kind of ran out of room here, so I'm just going to go to a second line. Times 0.3 squared times 0.6. So I'm just multiplying all those numbers together. And I get my rate is equal to 4.94 times 10 to the -6. So when I have those concentrations, then that is what my rate will be. Let's try this one. Determine the rate law and calculate the rate constant for the following reaction. Remember, you can't write a rate law just from the balanced reaction. I have to look at the experimental data. It will have this form though. Rate is equal to K times the first ion raised to the X and the second ion raised to the Y. So for the first ion, I'm going to look at the second and the third experiments. And let's set that up. So I have, let's see, which has the bigger number? Experiment 3 does. So I'm going to put the rate of the third one on top of the rate of the second one. Then we're going to put our numbers in. Simplify and get rid of common terms. So my rates, when I divide, I can get a 2. My constants are going to be the same because it's the same reaction. And I have 0.16 divided by 0.08, so that would be 2 to the X. And then these 0.017s to the Y's, those cancel. So I know that X equals 1. So that's my first value. So I'm just going to come over here and I'm going to just remind myself I worked this one out, and I'm going to put a 1 where that X is. Next, we can figure out the iodide ion. This time I'm going to look at experiment 1 and experiment 2. So the rate of 1 divided by the rate of 2. And I'm just going to go ahead and set that up. I'll plug my numbers in. Simplify and cancel out like terms. My rates become the 2. My rate law constants cancel. I can cancel out those 0.08 to the X. And I have 0.034 divided by 0.017. So that would be a 2 to the Y. Y is equal to 1. So I can write my rate law from this. And I'm just going to use the one I have above that. Y is a 1. So there's my rate law. The next thing I need to do is find out what K is. So let me just clear my screen. And I'm just going to rearrange this to solve for that rate law constant. So I'm going to have rate on top because I'm going to divide each side by each of those ions. And they're just to the 1 power. And let's go ahead and put our numbers in. And just pick one of the experiments and just go across and plug in the values. And I'm left with 0.080. And my units would be, it's a second order reaction, so I'm going to have molarity to the -1 and seconds to the -1. And that's because your rate is always molarity per second. So I have molarity per second divided by molarity, and that's a molarity. So I can cancel one of those M's, and I'll be left with one of the M's on the bottom. And that would be my answer right there.